Good morning, good afternoon, dear participants and all the speakers, eminent speakers from different parts of the world. This is a very important webinar. The topic is Catalyzing Sustainable Development Goals Through Water, Energy, Food, and Access. And in this webinar, we have eminent panel. I will just like to introduce the panel with the participants. We have Professor Dr. Ragab, and he is our President Honorary from ICID, and he is Water Resource Management Specialist at UK Center for Ecology and Hydrology. I welcome Dr. Ragab in this webinar. And we have speakers, Dr. Luxon from South Africa. He is a research manager with the Water Research Commission in South Africa and specializing in agricultural water management and transformative and circular approaches for sustainable climate change adaptation. Welcome, Dr. Luxon. We have Professor Tafadzwa from UK. He is a professor of climate change, food systems, and health at the London School of Hygiene and Tropical Medicine and director of the Institute for Natural Resources in South Africa. Welcome, Professor. We have Professor Dr. Ming-Che from National Taiwan University from Taiwan. He is a professor in the Department of Bioenvironmental Systems Engineering at National Taiwan University, Taiwan. Welcome, Professor Ming. Then we have Dr. Bassel from Texas University, A&M University. He is the Assistant Director for Sustainable Development at Texas A&M Energy Institute and Adjunct Assistant Professor in Biological and Agricultural Engineering and a Research Fellow at the Institute for Science, Technology, and Public Policy at Texas A&M University. Welcome, Dr. Bassel. Then in the last, we have Dr. Alok Sikka. He is with the International Water Management Institute, and he is in Delhi office, and he is representing India and Bangladesh since April 2016, and he has a wide experience of about 44 years in different fields. So I welcome all the speakers, and I welcome once again all the participants. And the chair of this webinar is Dr. Ragab. So I will request chair of this webinar, Dr. Ragab, to take the floor, please.
So thank you very much, Secretary General, and also thank you for introducing the speakers. That would save a lot of my time as well. Thank you. I will start by introducing the webinar, and let me share a few slides as part of the introduction. Trying to get it in the presentation mode. That will do. Yeah. Is that okay? Can you see that screen?
Yes.
Okay,
Yes.
thank you.
Yes, Dr.
Yeah, so that webinar actually is one of the series of webinars that working group conducted, And we had one in April 2024, and this is the second one in April 2025. And also we are planning a workshop in Bali, in Kuala Lumpur, Malaysia, in September this year. So I will just give an introduction to the subject and why is the Nexus really is important for us. Water is needed to produce energy, like hydropower. Energy is needed to extract, distribute, desalinate, and treat wastewater. And the food production requires both water and energy. The interdependence of these resources is commonly referred to as water energy food nexus. Is the nexus new concept and why it is important now? A lot of people, they think it's something new or we know about it before. The interdependence and interrelations between water, food, and energy were well known since the early civilization, which are known to have started beside rivers, like the one by the River Nile in Egypt, and also like the one in Mesopotamia, in the area between Tigray and Euphrates River. However, the use of resources more efficiently, that are the essence of the nexus, was not pressing issue during those periods due to the plentiful resources that exceeded the need of such a small size of populations at that time. So there was no really need to use resources efficiently as we need now because of the small population. So how actually that nexus started in early civilization? Mankind, they have been getting water out of the rivers and the canals by their own means to produce food. And they developed several methods how to get the water from the river to produce the food. And that was based on manpower as a source of energy. And then they used the livestock as power energy to drive wheels to get the water to irrigate. So it has moved from a manpower type of energy to livestock, and then the diesel machines were developed and they started to use the diesel machines to get water from the canal to the field. And then the first conference held to recognize the importance of water, energy, and the food nexus was held in Bonn, Germany in 2011. And in that actually conference, it was highlighted that we should adopt that integrated approach of the nexus. And that was the first organized conference in the world to highlight the importance of thinking in a more holistic way. And the nexus led to water productivity paradigm change. We always talked in the 70s and the 80s and the 90s about more crop per drop. And once the nexus came into light, that paradigm changes and the concept changed from more crop per drop to more crop per drop per kilowatt, and even now per unit of land. So how important the nexus is? The nexus can stimulate innovation and the use of new technologies. For example, of increasing irrigated land is limited by available traditional energy sources. The authorities might adopt non-conventional and innovative energy sources like hydropower, wind power, solar energy, extra, and also to adopt a new irrigation technology that are more efficient than the surface irrigation. In addition, the nexus could also lead to better governance arrangements via cross-sectoral water, food, energy frameworks and policies. Nowadays, some cabinets like Japan government, now they have part of the cabinets to look at the nexus of the three ministers. They get together, the Minister of Water, the one of the Energy, and the one of the Agriculture. They meet together to have one policy to address that integrated approach to water, food, energy nexus. It could lead to developing integrated management accounting for the nexus and the impact of climate and population changes. The nexus also has a different scales. The nexus that at the city level is different from the nexus of regional level, of the national level, and also the transboundary level. So each nexus here is addressed differently. It has different objectives and different means to approach. And later on, we started to think about how can we quantify the nexus. And that started in India and in Sydney. We started to see more papers coming with quantification and to put numbers against the word nexus. And the nexus index here calculated from water sub-index that looks into accessibility and availability, the energy sub-index, and also looks at energy accessibility and availability, and then the food also the same. And then the three sub-index were all combined to give us that index. And more than that, here a research from India by Krishna Mundal in 2022, he started to look at the different parts in a catchment there, where he can see how actually the three indices are presented and where the areas that has less water security and which area has more water security, and the same, which area has plentiful energy compared to areas they have less energy, and also in terms of food, which part is also insecure in terms of food, and also calculated the total nexus index from those three, the water and energy and the food, and then would look at this and to see where he can, or his group can modify which index of these can be modified to increase the total above all water, food, energy index in a certain part, and what trade-offs actually can take place. So we moved from quantifying to specially distributing that actually index and to see where actually in certain region or a certain catchment where we can improve and how can we improve. And that's actually a way forward nowadays. And Nexus was recently also associated with the Sustainable Development Goals, which is a subject of today. And it appeared to all of us that the Nexus really has something to do with the development goal number 2, which is a zero hunger, and also number 6, which is the clean water and sanitation, and also number 12, 13, and 15. So that's actually the subject of today, that we are going to see how can we link our Nexus to the to achieve the goals of these sustainable development goals. And we are planning in Kuala Lumpur in September, international workshop, also to look at the implementation of the water energy nexus for building resilience, adaptation, and sustainable socio-economic development. So I hope also you'll be able to contribute and to attend this important meeting of ICID in Kuala Lumpur. So I would like to thank you, and just I wanted to set the scene by giving few ideas about how we started and about the concept of the Nexus and why it is important and what the scale of the application and how it is linked to the SDGs. So with that, really, I hope I give you enough idea for the next session, which is really to have our wonderful, excellent speakers talking today more in details for that. So our speakers now will give you more details, and And I think our first speaker will be Dr. Luxon, Nhamo, and he was introduced already by Secretary General. So Dr. Luxon, you are invited to give your presentation, and we thank you for your coordination of that webinar on behalf of ICID and the working group, and all the efforts that you made to invite those excellent speakers to this webinar. Thank you. The floor is yours.
Thank you, Chair. I'm not going to have a presentation as such, as Prof. Tafadzwa is going to give a presentation, a combined presentation. But however, I'm looking forward to the presentations because the stage in which we are right now, I think we've developed quite a lot of modules throughout the globe, and the Bassel is here to give us, for me, we developed the first Wave Nexus model. So we are actually very much excited to be with him, and what needs to be done at the moment because of the depletion and the degradation, the insecurity of resources. We need to move forward, particularly considering that achieving the Sustainable Development Goals is almost impossible by 2030. So what we need to do is now to operationalize the water energy food nexus. How can we do that at the moment? We need to have a governance framework sort of in order to move the water energy food nexus from theory to practice. Colleagues, welcome to this webinar, and I'm very much excited and looking forward to your contributions. Back to you, Chair. You can introduce the first speaker.
Thank you. Thank you for introducing the subject and the importance of moving from theory to practice. So our next speaker will be Dr. Tafadzwa. He is also a UK colleague working for the Institute of Hygiene and Tropical Medicine in London. Welcome, Dr. Tafadzwa. You have 10 minutes. Thank you.
Thank you very much, Ragab. Let me share my presentation. Okay, thank you very much, everyone. I'll be giving a short presentation on catalyzing sustainable development goals through the WEF Nexus. I will also share at the end some key messages that have emerged from consultation that we recently did with sub-Saharan African states in Ethiopia in March this year on this very same topic. So just to highlight, I think Ragab already gave a very good overview on the importance of the WEF Nexus and why the WEF Nexus. I will contextualize it a bit in terms of Africa and the pressure that Africa has in terms of the triple challenge, or we have another nexus of poverty, unemployment, and inequality that is really affecting livelihoods and threatening sustainable development on the continent. And this is being amplified by climate change, which is really making it harder for people to earn a livelihood, especially from agriculture, through increased rainfall variability, reducing rainfall amounts, and increasing intensity and frequency of weather extremes such as floods and droughts, which make agriculture for most smallholder farmers more complex, more challenging, more uncertain, hence the loss on livelihoods, hence the increasing poverty and associated widening inequalities. We also have a challenge in terms of regional institutions that have issues in terms of coherence, collaboration, and partnerships and sectoral approaches. And that also impedes implementation even where there are good policies available. It becomes hard to implement them because of the sectoral approach and mandates. I will not spend much time again on defining what the Nexus is and again why it is important, except to concur and re-emphasize the point that Ragab made, that the Nexus is not a new concept, but it has always been there and it will remain there. We look at challenges in terms of, implementation of the SDGs or in terms of progress on the SDGs. And looking at Africa across many of the SDGs, particularly the ones of interest to the Nexus, which is SDG 2, 6, 7, 13, and 15, we note that many countries are facing major challenges. Major challenges remain, and there is stagnation in progress, and in several instances, there is decreasing, or a decrease or a regression in progress. So we are looking at the Nexus in terms of that context to see how can the Nexus help us to identify synergies, how can it help us to identify trade-offs and plan for investments that can be catalytic, that not only address a single SDG, but can be enabling, catalytic, and accelerate other interlinked SDGs, starting first with the directly linked one, and then the interdependent ones, which then brings almost all the SDGs into the picture. We have done some modeling work for the African continent using the Global Wave Nexus Index that was developed by Gareth Simpson and colleagues, which pulls in global datasets to calculate a Wave Nexus Index for at a country level using 3 pillars: a water pillar, an energy pillar, and a food pillar. And again, what we have noted is across most African countries, there is high unsustainability across the Wave Nexus. So the index pretty much gives a viewpoint or a way of assessing the sustainability of the 3 dimensions of the wave, and also highlighting where the imbalances exist. And a lot of instances, what we learned from this analysis was that in Africa, contrary to what we had always thought, that water is the most limiting factor, especially in agriculture, it turns out that energy is the most limiting factor, because in many areas there is economic water scarcity, but energy poverty limits the distribution of water. And even so, in irrigation, energy poverty limits our ability to irrigate. And we also look at it from a perspective of water scarcity in Africa, which we know is increasing under climate change, especially in the middle of Africa, where it has always been scarce. That scarcity is increasing. And the worrying thing about it is it's also accompanied by high temperatures, which then result in high evaporation rates, which also make it challenging for farmers to plan and manage irrigation, just irrigation scheduling. So the uncertainty involved in both rain-fed and irrigated agriculture is becoming challenging. Hence, in many areas, the interventions are focused on, increasing access to water for irrigation and those sort of things, which is creating trade-offs. So climate change, really, to contextualize it, is massively impacting Africa, as this illustration shows, across all sectors. So the impacts on water scarcity and food production are mostly negative. The impacts on health and well-being are again negative. And this is an area of work that we are now focusing on. And that I think even as the ICID, we need to really look into the impacts on health and well-being and how irrigation can contribute in terms of addressing climate change impacts on health, especially from the context that new research that has emerged is showing that the greatest climate risks to water are going to be water quality related, not water quantity related, and the rising use of unsafe and untreated water in irrigation, especially around peri-urban and urban areas, especially for vegetables, and the implications of that on food safety and foodborne diseases. So that's an emerging area that I think we also need to look at as irrigation managers or planners. Now, looking at this, further contextualizing it within the concept of the planetary boundaries and what it means, we see from 2009 to the latest, which was in 2023, that we have already breached the threshold for the boundary for freshwater use has already been breached. And in many instances, irrigation or agriculture is, having involved because on average, especially in Africa, agriculture withdraws about 72% of water. So how do we manage water in agriculture in a way that actually is conscious of that boundary, in a way that retains or releases water for environmental flows and contributes towards broader ecosystem health? And also, how do we manage agriculture and the expansion of irrigation in many areas as an adaptation strategy so that it does not drive further land use change as it has done in certain instances? So how can we manage irrigation expansion and development in a way that does not drive land use change, in a way that does not then create biodiversity loss? So those are some of the implications, again, that we need to think of in this context. And this is where it becomes important for us to be able to integrate climate, food systems, and health, and through an understanding of the trade-offs between water, energy, food, climate change, and human and environmental health. And we are now talking about what we call a WEF plus nexus, to say we need to manage the nexus in a way that considers the broader dimensions that are also interlinked and interdependent on these three resource bases, such as ecosystems, health, land use management, and related outcome areas. So the research questions that we are particularly focused on are looking at how the Nexus approach can support systems transformation to deliver sustainable and resilient food systems that are healthy, equitable, and inclusive under climate change. And how can the Nexus approach be applied to enhance use and scaling of planetary health sensitive innovations? By that, we just mean innovations that provide benefits for both people and planet, because our health is interdependent. Human health depends on a healthy ecosystems. Healthy ecosystems depend on human interventions and human management. And also, how do we support capacity building and strengthening so that we've got people who are able to undertake Nexus type assessments, develop such Nexus informed interventions, and be able to jointly monitor and assess performance across the different dimensions of the Nexus. We have done a bit of work in South Africa on understanding or connecting with Nexus indices to the SDGs. I shared earlier on assessment using the global Wave Nexus Index. We have another tool, which is called the Integrated Analytical Wave Nexus Index, IWF. And again, that is developed to look at pillars related to affordability, stability, access, mostly security related and linked directly to SDGs 2, 6, and 7. And we have been using that sort of analysis to be able to track progress on SDGs across those dimensions. And the analysis we've so far done, that's an example of looking at 2015 and 2020, which is basically showing that the continued focus on food self-sufficiency in the Southern Africa region because of issues of food security continues to create imbalances or trade-offs. So the continued focus on food self-sufficiency, and as we see by 2020, the improvements in water productivity associated with that, but it's creating trade-offs across other dimensions as well because of the implications of that in terms of increasing water demand, increasing energy demand, and so forth. What we have then done is to build on those sort of analysis and the understanding that I've shared to try and develop a framework for how we can link the Nexus and SDGs much better, and how we can drive policy coherence, mostly to improve the implementation, collaboration, and partnership across different sectors. So this is a framework that we have developed. It calls for transdisciplinary actions that enhance cross-sectoral collaboration and governance of WEF resources and to address or respond to the environmental and societal drivers of change through cross-sectoral and transformative interventions that are responding to the SDGs, in particular SDGs 2, 6, 7, 13, and 15, as I mentioned before, through a framework that combines our analytical tools, the models that we have, actions or that are planned or targeted towards accelerating and catalyzing the SDGs and overcoming barriers to progress or barriers to achieving the SDGs. So this is just a simple framework that we have conceptualized, a conceptual framework in terms of how we could move from the theory of the Nexus towards implementing it to achieve outcomes in the people space. So some key messages from the workshop that we recently had in Addis, where we spoke about how the Nexus can catalyze sustainable development, in particular the SDGs in sub-Saharan Africa. There is a strong need for multi-sectoral collaboration and coordination and policy integration, because that's where trade-offs usually emanate. We need to invest in capacity building and strengthening so that the discipline or the area of the Nexus actually has people in strategic positions who can think, act, and plan in that way. We need to focus on local solutions to global challenges. So the presentation that Ragab gave, which showed the different scales, we need to think about how do we link local interventions in a way that creates benefits, system-level benefits that can cascade across the different scales. Because if we don't usually local level issues create system-level trade-offs across those different scales. So we need to plan local to global. We need to address or deploy the Nexus in terms of investment. How do we screen and develop Nexus type investments so that investment planning takes into consideration the multiple dimensions, so that we're not just investing in irrigation alone, we're not just investing in energy alone, but we're investing in integrated investments that are enabling across the various Nexus dimensions and the interdependent ones. In Africa in particular, we need to focus on empowering youth, participation in the Nexus space. And again, this has to be linked to finance. The energy sector, energy is a critical enabler for the Nexus and sustainable development in the African context. So we need to find ways to rapidly deploy and responsibly scale renewable energy solutions in the Nexus space. So we need to deploy them fast, but responsibly, learning from lessons from India on solar-based irrigation and some of the trade-offs that came out of it. So how do we rapidly deploy, but also scale responsibly? We need to develop WEF Nexus scenarios so that we can plan for the increasing complexity, risk, and uncertainty that decision makers often have to deal with in making decisions. So we need to develop scenarios. Currently, all the models that we have give status quo assessments. We need to be able to do predictive modeling using these scenarios so that we can look at probable futures and be able to inform more long-term and strategic decisions. I will end by highlighting that we've got a global WEF Nexus community that you can all join. We've got a page on LinkedIn. Some of the people here, like Bassel, are already members of that community, and we aim to use it as a space for sharing knowledge, data, and tools, coordinating capacity development. We do a lot of activities together. So please come and join. Please feel free to come and suggest activities. And that's just a slide from last year's WEF Nexus Winter School in South Africa, where we had a good class of about 30 participants from across Africa. So thank you very much, colleagues.
Thank you, Professor Tafadzwa. This is really quite a lot to digest in 10, 15 minutes. It's quite a lot of work, but thank you for highlighting the importance of the Nexus and also the constraints in applying the Nexus in Africa, especially the sub-Saharan Africa countries that you showed in the slides. And also that you mentioned the constraints in applying and meeting the Sustainable Development Goals and how to accelerate the work towards the Nexus in Africa in general. And also you have been presenting some modeling work for sub-Saharan Africa and how the indices were evaluated for 15 countries in sub-Saharan Africa. And also you mentioned the importance of integrating the climate change impact and water management and health, water security, food security, and the human system into the Nexus work. And also to understand the trade-off between water, energy, food system, environment, and health. And also you have been presenting a framework which is really important for everyone working in that field. And the framework really contained very important elements like the drivers of change, the risk and exposure, the intervention and risk reduction, and the resilience and adaptation. And you ended your also presentation by a very good key messages like the strong multi-sector collaboration and capacity building, focusing on localized solutions, as well as paying more attention to the innovation and the finance mechanism, and also the rapid response to the scale and the changes of the climate. I would like really to thank you very much for this information that enriched our knowledge about the way forward and how can we move forward and meet the Sustainable Development Goals. Thank you very much. So it's now time to, the discussion will be after all the speakers. So if you have a question, put it on the chat box and we'll get back to you at Q&A session. So now I have to move on to our next speaker. Our next speaker is the secretary of the working group on Nexus of ICID, Professor Ming-Che of National Taiwan University. The floor is yours. Thank you.
Thank you very much. I'm gonna share my screen. Okay, so can you see my screen? Hello?
Yes.
Can you see?
Yeah.
Okay,
Yeah.
no problem. All right, I'm gonna start. So thank you very much to having me. I'm very happy to be here. So today I'm gonna talk about the Nexus analysis of water, food, energy system for sustainable resource management. So I'm Ming-Che, I'm from National Taiwan University. I'm also from the CTCID, and also I'm a member of the working group Water, Food, Energy Nexus. So I'm very happy to be here. So I'm a modeling person. I do lots of optimization and also decision making. So today I'm gonna introduce the model we built for the water, food, energy nexus. So we all know that water, food, and energy are very important resource for human society, and sometimes it's complicated, and it has lots of interactive influence on each other. So this research, we try to analyze the nexus between the water, food, and energy system. And we also build a system dynamic model for the sustainable resource management. So we try to optimize those water, food, and energy simultaneously. But you know, we all know that we cannot optimize all those resources together. So we need to see the trade-off between those three resources. So we build a system dynamic model to investigate the interaction between water, food, and energy resources. So this research, because the limit of the time, I'm gonna focus more on the modeling and also the tool we build up, and also we're gonna provide a very simple case study in northern Taiwan. So in these slides, you can see the three main element we're talking about. In the lower part, you can see the water, and the upper left, you see the food, and the upper right, you see the energy. And from the water, we have the water resource system, and then provide the water for the agriculture, industrial, and also domestic water demand. And the agricultural water demand can supply to the food production. So from the water, it's connected to the food. And for the food production, we can produce food. Sometimes we also produce some energy crop, and also some agricultural residue can use to generate bioenergy. So food can also connect it to energy. And also from the water supply, we have the reservoir system, and then we can also do the hydropower generation. So from the water also connected to the energy, and energy also provides the energy supply to the food production and the water supply. So in our system, we consider the connectivity between water, food, and energy. So this system dynamic model are used to examine the interaction between those three resources. In this model, we consider water supply, water consumption, energy production, and also energy consumption and agriculture production. So in this system, you can see that the connectivity between those three resources. And in this model, we try to use the NetLocal system to build the model. And NetLocal model is a very popular and powerful system, and it can use to simulate the dynamic systems and also some agent-based interactive simulations. So in this model, in our research, we're gonna use this platform to build our water, energy, food systems. So as I just mentioned, in our model, we have multiple objective functions. We try to maximize the food production. We also want to maximize the energy production, and we want to lower the water supply risk. So you can see that there are multiple objective functions in here. And I'm not gonna go into the detail of those mathematical terms, but you can see that we try to maximize the food energy production and also lower the water supply risk. And in the constraint, we also have the mass balance equation for the water resource. And also in our model, we can decide which crop we're gonna grow in our farm. And also we have the water demand constraint, and also the in the following constraint, we calculate the energy production, and also the water supply need to be greater than equal to the water demand. And also there are some capacity constraints for the water resource systems. And there are some more non-activity constraints in the following. So based on this model, we have the multiple objective function, and also we have the constraint, the constraint in here. So if we have try to optimize our objective function and subjected to those constraints, we can try to maximize our multiple objective function and then try to see the trade-off between those objective functions. And here is the conceptual diagram for the system dynamic model. You can see that in here we have the mass balance equation for the water. So in this model we have the water supply from the rainfall and also from the upstream river. And from the we also consider the water supply to different purposes. And in this model, we also consider the agriculture crop production. And in here, you see lots of blue arrows. So those water demand is a function of those agriculture production. So we use those blue arrows to connect those interactions. And in this model, we also consider the hydropower production, and also some water production will use to supply the water resource system and also agriculture resources. And once because limit of time, so I don't have the time to go into the detail of the model. But if you are interested, I'm willing to provide the details of our model and also the softwares. So, but in here we have a case study. So that model is used for the water, food, energy Nexus systems in northern Taiwan. And in this water resource system, we have Shimen Reservoir, water resource reservoir in here. So this is the upstream and this is the downstream. And this the water is supplied from the reservoir to irrigate the farm. So in this area, we have 36,000 hectares in Taoyuan, and that's include the 24,000 hectares in the Taoyuan Irrigation Association, and also another 1/3 farm in the Shimen Irrigation Association. So in this system, we consider the water supply system in here and also some irrigation in the downstream. And this Siemens reservoir also have a hydropower productions. So in here, we use this model to build the interface for the users use. So in this users interface, you can see that we have the water supply and the water consumption in here, and we have the electricity consumption in here, and we also monitor the food production, the rice production along the 1 year, and in here you also can set up and put your input data in here, and then try to simulate the system dynamic model. And once you start to simulate this model, you can try different scenarios. And after you try different scenarios, you can compete. You can try to find the optimal solution, the compromise solution. Once you consider the trade-off between those three objective functions. And here is some visualization between the interaction. The water goes to the agriculture, and also agriculture use some energy from here, and also the water need to be use some energy. Okay, so that's my presentation, and thank you for being here. And if you want to know the details about our model, or if we are interested to apply our model to your case study, you are feel free to contact us, and we would love to provide the details about the model. Thank you very much.
Thank you very much, Professor Ming-Che. Oh, and it's once again one new really model we are not aware of, net logo. That's a system really was interactive simulation, which is nice. So you can see immediately if you increase or decrease one element, you see the impact straight away on the screen. So that's really one of the advantage of using these interactive models, and also the optimal control issue is really very important also for us in designing. So if really you want to design a system, you will have to use that optimal control idea, so you can use all the resources more efficiently and to optimum level. And also the trade-offs, as you showed in the last screen, with cases of places in Taiwan, especially paddy rice areas where the water consumption is high and the demand on the reservoirs is also quite high when you have a paddy rice. And it's really nice to see the modeling work advanced to that level. So thank you really for enriching our knowledge with this new model, and we hope really some of the members of the working group and the participants can make good use of that interactive model. Thank you. Well, once again, the questions will be in the session following all the speakers. So let me now invite the next speaker. Our next speaker is Dr. Bassel is the Assistant Director of Sustainable Development at Texas A&M Energy Institute, an adjunct professor at Biological Agriculture Engineering, and a research fellow at Institute for Science, Technology, and Public Policy at Texas A&M. Dr. Bassel, the floor is yours. Thank you.
Thank you, Professor Ragab, for the introduction, and thank you for ICID for organizing such a timely webinar and for inviting me to be part of this panel. Let me share my screen. Today, I'll be talking about a project that we've been working on in Texas, specifically, which is actually very much aligned with the topic of the webinar, focusing on localizing the SDGs in San Antonio, Texas. But first, I'd like to maybe reiterate some of the key interconnections that we're talking about that motivate the need for looking at these key resource systems and projected demands in a systems approach and as a nexus. If we look at projections by 2050, we're expected to need 20 to 30% more water, 50 to 60% more food, over 50% more energy by 2050, with growing global population, with trends including climate change, shift in land use, migration, conflict, etc. While these are grand challenges, they are also very much interconnected. As we heard from Dr. Ragab's presentation earlier, 70% of our water is used by the agricultural sector, 15% of our global freshwater withdrawals go for energy production, and 30% of our world energy is consumed by the food sector from farm to market. And that's at a time where 2.2 billion still lack access to safe drinking water, more than 700 million people still suffer from chronic hunger, and more than 700 million still lack access to electricity. Now, these, again, are grand challenges, are complex challenges, are interconnected, and they will take different shapes, forms, levels of urgency in different regions, different contexts, depending on resource availability, depending on technological capability, depending on human resource capacity, and governance structures. And I'd like to illustrate through this policy brief that we have published actually with IWMI and ESQA that came as a result of a regional dialogue we did a couple years ago, looking at different intervention or action areas that are required to address water, energy, food nexus hotspots. And you can see the complexity and the diversity of the different dimensions that we need to keep in mind as we look at addressing these complex hotspots, from looking at data analytics tools to better understand and quantify the trade-offs associated with different interventions across the resource systems, looking at governance and policy coherence across the different sectors, ensuring we have the right enabling environment and mechanisms for science policy dialogue, stakeholder engagement, and ensuring that we are representing local context in the solutions that we're looking at. Also very important is capacity building, ensuring that those who are involved in managing these resources have a common understanding of the level of interconnectedness of these resource challenges and are aware of the different tools and opportunities for cross-sectoral collaboration. Also, last but not least, ensuring that we have the financing mechanisms to scale up different successful innovations across different scales. So from there, I'd like to jump quickly to the case study that we've been working on in Texas with the limited time that we have. This is a case study we've been working on for the past few years in the San Antonio region, which is one of the most rapidly growing cities, urbanizing centers in Texas and in the US, which also is neighboring the Eagle Ford Shale, where a lot of hydraulic fracturing happens, which is also a water-intensive energy source, as well as the area being surrounded by a lot of agricultural production. Now, to give you a sense of the region that we're talking about, this might illustrate these growing sectors and potential competition between them. All of these dots you see on the map are water wells. The blue dots are water wells for municipal use. The green dots are water wells for agriculture, for irrigation, and the red dots are water wells for energy production. And we can clearly see in a region where all of these sectors are projected and planning to grow over the next 20, 30 years, that unless there's some level of communication, coordination in terms of the planning across these sectors, that we might have some competition between them. So we ask that specific question: how much are these sectors communicating and coordinating? So we administered a survey that was sent to more than 100 water public officials in the San Antonio region, asking them that specific question: how much have you communicated in the past year with other water, energy, food, and cross-cutting stakeholders? And cross-cutting meaning stakeholders like the mayor's office, for example, sustainability office, which have more of a cross-cutting mandate. 90% of the responses we received showed zero communication whatsoever with any of the water, energy, food stakeholders in that region that I just showed you. Out of the 10% that showed some level of communication, you can see that the surveyed water public officials are the green or the gray dots. You can see most of those connections are with other water public sector officials. So we see some communication. So whenever communication exists, it's happening mainly between water and other water players, and much less with energy and agriculture. And as we look at more frequent levels of communication, this is the same network map. We're looking at weekly communication. We can see that most of that network map drops, and mainly water to water connections are the ones that remain. So as part of engaging with stakeholders and reporting back on the outcome of this survey, we ask the question: why do you think that is the case? There clearly seems to be a need for greater coordination between the sectors, yet it doesn't seem to be happening. So some of the barriers to communication that have been communicated to us by the stakeholders in San Antonio, one is institutional mandates and lack of coordination mechanisms. So one of the key reflections from that workshop was we know that this competition exists, and we are planning to grow across these sectors, but it's not part of the mandate of my organization or my institution to be doing this kind of integrative planning activity. So unless there's a specific mechanism to do that with financial and human resources that are allocated to that, it's not going to happen on its own, just simply because people are aware of the need to do this kind of communication. So ensuring that we have the right mechanisms and mandates that allow organizations and institutions to do this kind of integrative planning is very critical. Other barriers that were mentioned were included the planning horizons, where you see the water sector, for example, developing a 5-year water plan, state water plan, where the energy sector is looking more of a 2050 decarbonization horizon, which also creates some different priorities and different ideological differences across sectors. That is in addition to lack of uniformity of language between the different sectors and lack of common goals and collaborative projects. And this is where I would like to highlight how we have used the SDGs as a platform that could bring those stakeholders together, that could help in catalyzing that dialogue that needs to happen across different sectors to better understand how interconnected those sectors are, and to evaluate interventions across these sectors. So over the past year and a half, we've been doing a series of workshops with the community to localize the SDGs in San Antonio. We did about 5 goals per workshop, and we've been specifically asking the question. So starting with the targets and the indicators that are recommended by the UN and at a national level, starting with those as a starting point and asking the community, are these the right indicators for us? Or first of all, how do you define water security? How do you define energy security? What are the key goals for you in terms of food security, and what are the key challenges, and what are the specific metrics you would like to use to evaluate progress toward these goals at the city level, at the San Antonio level? And I can tell you, we went into deep discussions and more than 50 indicators that are not part of the initial list of indicators, the 260 something indicators that are commonly used, emerged from these discussions, in addition to many interventions that were part of that discussion. And if I can mention a few, in addition to the water, energy, and food goals that and indicators that surfaced, discussions related to inequitable development in the city and across different parts of the city emerged part of that conversation. Conversations around where industry and energy production is placed and its impact on air quality and on health indicators and as a result on education outcomes of those specific zip codes because of bad air quality and impact on student absence rates at universities. So again, this having this platform allowed us to have those cross-sectoral conversations and with a lot of these indicators and relations that emerge, which otherwise would be hard to do. So this dashboard that has been an outcome of this exercise now includes a list of the different SDGs that have been, or different indicators that have been identified by the community with data over the years that highlight different trends. So you can see here, for example, we have the UN target, the UN indicator, and then the localized indicator for San Antonio. And it was a very rigorous exercise and iterative exercise in terms of finding, first of all, looking for local data where it exists, at what resolution. Do we have it at the zip code level? Do we have it at the city level? Do we have it at the county level? And different data is available at different scales. So that was also part of the exercise. But again, we are at a stage now where we have 10 of these SDGs mapped and allowing stakeholders in the region to evaluate trends for these SDGs and to evaluate the impact of different programs that the city is developing as part of their climate action plan and different sustainability plans. And we didn't stop there. We took that dashboard and going back to the importance of capacity building and building systems thinking in the future generation and future leaders of systems thinkers, we took that dashboard to class and we basically asked students to evaluate the climate action plan and the different programs that the local electric utility company is leading to map the impact of those programs on SDG 7, but on all of the other SDGs that are connected with it. And students use that dashboard with the localized indicators to basically serve as consultants, so to speak, to the city to say, these are programs that are impacting our SDGs, or SDG 7 and SDG 13, which are a focus of the electric utility company in terms of looking at the climate action plan. But also these are some of the other potential or existing synergies and trade-offs that need to be better understood and communicated as part of revisions and scaling up studies and potential of these current programs. I am aware of the limitation of time. I'd be happy to go into more details over those, but I'd like to wrap up with really highlighting how systems thinking is at the core of what we're discussing here and being able to better understand the interconnections between those sectors and evaluate trade-offs and synergies across SDGs is critical. Engaging communities in co-identifying those sustainability indicators is very critical. And the goals of different communities will change from one place to another. Their priorities will change, and therefore it does make sense that indicators we use to measure progress toward the goals for different communities with different goals would be different. I would say that the SDGs provided a platform that allowed for that cross-sectoral dialogue to happen and helped us reveal some of the interconnections and the sustainability trade-offs that are often overlooked. It also helped in aligning multi-level governance and financing mechanisms and help in prioritizing some of the programs that have several synergies and positive impact on several of the SDGs for the community and identify some of the shortcomings and trade-offs associated with some of the programs which require some revisiting. I'd like to reiterate the challenge that is related to limited data and data resolution, which can also be very critical in masking some of the interregional disparities. So if we look at data related to water access, for example, or energy access at a larger scale, at a city scale or a national scale, it does mask some of the interregional, some of the local disparities that we otherwise would not be able to capture. So it's really critical that we collect that data, and we are aware of that challenge that comes with lack of high data resolution. And last, I'd like to say that SDG localization serves as a lever for sustainable and equitable development, and by helping us to anchor those global ambitions and local realities and local limitations to ensure that we have inclusive cross-sectoral pathways for transformation across the different sectors. In terms of the next steps for this dashboard, it's currently not publicly available yet. We're working on that as we speak, and we plan to have it publicly available to the community and to the broader research community as well, and try to look at customizing it for other contexts as well. We're looking at ensuring that it has, in addition to being able to track trends and evaluate the impact of different local programs on the indicators, to do some scenario analysis that allows also for capturing some of the interconnectedness between the sectors. And we're looking at making it also more a spatial tool with the data that we have, allowing for highlighting some of the key hotspots. So I'll stop here and would be happy to entertain any questions in the Q&A. Thank you very much.
Thank you very much, Dr. Bassel, and we'll keep the questions to the question session, and that will come after our next speaker. But thank you, really. Now we have seen a dashboard. So, and the first, was the first speaker, we got a framework. Second speaker, we got a model, interactive model. And the third speaker now, we're giving us something else to look at, the dashboard. Dr. Bassel really has highlighted the need for the Nexus, given the possible need for more water in the future, and energy, and food. And also he gave us a case study from San Antonio, Texas, and also the questionnaire that results that he presented by talking to the stakeholders highlighted also there is some really little communications, and if any, will be only between the water agencies. And also he evaluated the progress and the barriers for why we cannot really go further with the SDGs. And he highlighted the legal and procedural and financial and the language and planning horizons and different value systems to be some of the reasons making that barriers, in addition to the competition and self-interest. And also he showed us part of the capacity building with the students and how we can get a local indicators. And in the dashboard, different indicators were included, and also the building new indicators would be really quite important to go ahead, and the key messages telling us we have to think in terms of system, and system thinking is really quite important. Cross-section dialogue is quite important. Multi-level governance and finance mechanism is quite important. And also we have to be aware that we need more data and not to have many gaps in our data, and to have a data of good resolution at the same time. And really we have to be thinking about the SDG localization and the level of system and equitable development, and the dashboard really is something that we should maybe pay attention to, and think about moving up from the local scale or the way up, and to be able to meet the development goals. Thank you, Dr. Bassel, and we'll come to the question session should any of the attendants would like to ask questions about the dashboard. So now we have our next speaker, the last speaker of today, Dr. Alok Sikka. He's the International Water Management Specialist at Institute of IWMI at Delhi, and have been working with him in several workshops, and we organized together so many really activities related to Nexus. So thank you, Dr. Alok, for really coming also today to give us more knowledge and information about your work that's in progress. Thank you. The floor is yours. Thank you.
I hope my screen is visible.
Yes, thank you.
All right. Okay. So thank you, Professor Ragab. And I think when you are the last speaker, it becomes easy because most of the things have already been told. So I'm really not going to, I don't have to set the scene or context because the context is already there. And what is that? And just to let me say one thing, that we know that with the demand overall increasing in all the sectors, particularly in agriculture for irrigation, and the dependence on groundwater as well as the energy particularly in the South Asia and most of the Asian part of the country, globe, and also in the sub-Saharan Africa, also as you can see in some of the places, not only just energy there for the groundwater extraction, but also for the surface water lifting as well. So that is something that really we have to be saying, and I think that this has already been amply indicated by other speakers. This interconnectedness is really very important, and one has to really look into that how best we can look into this to try and see that we can put it in practice. Because so far, as Professor Ragab, you said that we started off in 2011 and 12, and everybody is talking more as a concept, but now slowly we are trying to move towards getting into the modeling, getting into the indices, and perhaps now in practice, how best we can really go into the future, and also looking at managing water with a nexus lens. Otherwise, it becomes a siloed approach. And that is something which is really important. And while doing this, the way we are looking at it, and I look at it, my focus is that when people are looking into this SDGs in every country, in every region, in the race of getting the more numbers, they go on looking into expanding their envelope in a more siloed approach. And maybe if they do something good for water, maybe it's bad for energy and vice versa. So that is why, while looking into the race of speeding up and catching up with the numbers of SDG, when they are doing the monitoring, it's also important that they look into a more systems approach and trying to see the interconnectedness rather than just looking at their own sectoral or departmental numbers. So the way we are working on that is, as Tafadzwa and others have indicated about those various indices, because we know that earlier there were no indices. Now here we are following an integrated modeling approach. Together with the scenario building and the dashboard, so where we are looking into various evidences in terms of resource interdependencies and balance between the demand and the supply, the climate change impacts, and the unsustainable practices, and then how we look into this modeling approach and then run it through the scenarios to see that how, in a more strategic framework of balancing water, energy, food nexus, we can see that the connectivity with the SDGs. And particularly when we look into the WEF nexus, we see that 14 out of the 17 SDGs are directly or indirectly are linked with this kind of a nexus approach. Now, the entire scheme of things which we have followed and which we are pursuing is including the integrated modeling and plus making use of some of the indices, because we are using modeling here not for the modeling per se, the hydrologic models, but how best we can use the models in trying to derive and run through those various composite indices towards water, energy, and food. So here we have used, our innovation is that we have used integrated the SWOT model with the GPRO model. So we are doing integrated surface and groundwater hydrology modeling. And this one is at a very big basin scale, of course, with over 6,000 HRUs, hydrological response units, because we want to do it in a distributed way. And then we are looking into that how to identify the hotspots, looking into maybe from over exploitation of groundwater or low water efficiency or the low crop yield and stuff like that. And then we have come up with like the composite index. We call it WEF index. And here the weights are not like a uniform weightage. We have given a variable weights which are dependent on the data itself. It speaks about the weights. And in order to simplify for the user, as you will see in the outcome, we have put everything in a dashboard, a decision support system, where user can simply go there and run through those DSS to see how best we can bring in the policy convergence and the coherence, and also instead of having a siloed approach to looking into the SDGs kind of catching up, how best we can look at it in a more cohesive and convergent manner. These are like the variables which we are deriving out of these models. And of course, there are some derived variables, and they all have got the interconnection with the indicators which are required in the SDGs indicators. The way our dashboard works is a dashboard for Nexus assessment. And as I mentioned to you that we have a variable database, we put it through the model calibration as usually we do. And then we get into the scenario generation. And then, as you can see on the left-hand side bottom, these are the kinds of the scenarios that we are building upon with business as usual. How about if we increase the area under irrigation under different crops, maybe more water consuming, less water consuming crops, and increasing the efficiency of irrigation, and how with the supply side augmentation, the recharge is increased, and then the crop diversification to try and see that how best we can replace sugarcane with any other low water consuming crop, and so on and so forth. So that is how that we try and run it. And then at the end of the day, we get the composite index calculated for each and every those hydrological response unit or for any smallest unit or the district. And this is the picture of our WEF dashboard, where you have various features. You can run the scenarios, you can have the land use management, irrigation management, and you can visualize map. And finally, you can also get the display of water, energy, food nexus indices. The way we have worked it, like the others have been also talking about, and you also mentioned in your own keynote, that we looked at those three pillars of water, energy, and food in terms of their availability, and productivity. And then we have normalized the indices and we come up with the integrated WEF index. Of course, we can have a radar charts and the maps or the way you want in a tabular form. You can always look into those kind of things. The way we have calculated this trade-off indicators, as you will see that on those triangular 3 axes, water, energy, and food. And this is just for an example in the entire Ganga basin, which is a huge basin, about 1 million square kilometer. And where this is, for an example, we have shown the water energy food nexus, in this case is 0.55 for that particular HRU, which you can see on the map. And so this shows the synergy as well as the trade-offs, as you will see. Now, the issue is then how best we can get into this to play around by changing various scenarios to make it more optimal looking. Now, in order to do that, because as we know that when we are looking into this SDGs, our water, energy, and food, these 3 pillars, various SDG targets are there under various SDG indicators like 6.4, 5, and all those things, which I'm not going to repeat that. And then what are the nexus sensitive indicators which are embedded in our scheme of things, which we get, which have got a direct relevance with that. So this is just to show the kind of the linkage across with that. Now, this particular slide shows that a simple run of that, and this is the running of the scenarios in the Ganges basin, where what we are telling is that we are running this scenario for increasing the efficiency by 20%, and in the districts where groundwater development is more than 75% and existing irrigation efficiency is less than 60%. So that when we do that, then how does it look like? So see all the dark blocks which you see, those are the districts which qualify, or those are the districts or the HRU which qualify to be covered under this scenario. So when we run the model, it will run only for these kind of dark, highlighted blocks, because they are qualified to be in the category of where the groundwater development is more than 75%, means we are over extracting the groundwater and the efficiency is also low. So that's something that to see. And like this, in this entire Ganga basin, we had 77 such districts, and within districts, of course, there are a number of HRUs. Now, for the sake of the comparison, you'll see on the left-hand side, this is the business as usual at present. So the maximum, you can see our WEF index is like up to about close to 0.2 to 0.4. And because these are the districts, as I said, where overexploitation of the groundwater is also taking place. And now, once we run it through by increasing the efficiency by 20%, you can see on the right-hand side, where is the percentage gain in nexus? Means what is by doing this, how much water, energy, food nexus gain is there, what we are telling about the nexus gain in terms of change. So you can see with this changing efficiency from the base level value to 20% in those overexploited groundwater areas, we could raise our level of index, composite system level index, by over 10%. So it means it is not enough, we have to do something more. Now, the next thing here, the same thing, what you will see, if I have to do it for each and every district, few districts, for an example, in Hapur in Western Uttar Pradesh, wherein you will see that this one, just as an example, I'm showing here, you see the water things has gone up. So it means here, this is more towards improving the SDG towards water, but of course, keeping all the other things also, energy is also on the increase. Food is not getting reduced. It remains where it is. Similarly, in another districts, Palwal, there you will see that this is more apt for the increase in energy, but at the same time, water is also getting increased. So there is a kind of a balance. And say is the case in Bulandshahr, we are just showing in there is a marginal increase in food, but not at the cost of water or energy. So this is how that you can, it has been depicted in a way that you can see that how it is really playing a role. Then we take another scenario where we increase the groundwater recharge by putting various supply side augmentation on minor aquifer recharge or artificial recharge and other kind of things. Again, in the same blocks where groundwater development is more than 75% and irrigation efficiency is more than, so here we increase the groundwater recharge, and you will see again here in this case there has been more than about 10% gain. Now, the only thing which we need to look into, we have not run it so far. It means that neither efficiency alone nor the recharge alone is going to really take us to that level of desired level of reaching to the water energy food nexus. We have to then combine it together perhaps to reach to that particular kind of a level. And the same thing we wanted to depict here, that how in some other districts, by doing that, we could reduce the water stress. In some other districts, we could reduce the energy use efficiency and intensity of energy, and also at the same time in terms of the food. So the thing is that for everything at the district level or at any system level, you can try and look into that how really it is behaving and whether we are going negative towards nexus or gaining towards positive nexus. So finally, I leave you with the message that naturally, when we are looking into this, we require an integrated and systems-based approach to increase productivity, but of course, not at the cost of water and energy use efficiencies and the environmental health. And it is also important to understand and analyze the trade-offs and synergies, particularly when we are talking about the ag water management interventions, and we have to look into them with a WEF nexus angle. And these are also to catalyzing the SDGs, but to keep in mind that a more holistic way, not as I said in the beginning of my introduction, that in the race of attaining good numbers for water sector, you run down the energy sector and vice versa. So it has to be looked into in sync with the interconnectedness and in sync with the kind of this nexus approach. Now, that is where the policy coherence will be brought in. And going forward, as Professor Ragab you mentioned, that's what we are feeling that now, how best we can put this entire nexus modeling or nexus approach into practice. So this is what, like you have seen this, we wish that we would like to now take it to the field and validate with the actual situation so that this could really be. So with this, I thank you very much, ICID and Professor Ragab, for having given us time. Over to you, Professor Ragab.
Thank you, Dr. Alok. Thank you very much. Very interesting, really, subject, and also different dimension to our water resources. You highlighted really quite important issue, the over abstraction of the groundwater, which is really happening in so many arid and semi-arid areas around the world. And there are so many countries really over actually abstracting their groundwater, and the recharge cannot cope with the abstraction rate in so many areas. So thank you for highlighting the importance of looking into the groundwater and manage the sustainable the groundwater in more sustainable way using the nexus. Also, thank you for showing us the pathways to the sustainable development goals, and also the link that you mentioned, that 14 to 17 of the sustainable development goals are linked to the nexus. That shows how important the nexus is for sustainable development goals. And also you highlighted the fact that you were using SWOT catchment scale model linked to the groundwater in order to identify the hotspots in basin scale, and also that would lead to getting information to dashboard, and also helps you to develop decision support system and policies. The scenarios also you showed are very important. Business as usual, it doesn't seem to be the good option, as everyone would know, expect. And also your scenarios about increasing the irrigation efficiency by 20 and 30% in areas, and how that would impact on really the nexus and the indicators. And also your key messages, also once again, saying like other speakers that we need to adopt the integrated approach for the management of the three elements of the nexus. And also you also highlighted the importance of the trade-off, and also the need for tools to be used to actually drive new policies. And also, as you mentioned, the last statement, we need to put the nexus into practice. And that's really the main topic of Kuala Lumpur workshop. In Kuala Lumpur workshop, we put in the title there is practical examples are needed for the workshop. So we need really some sort of good examples to show how the nexus can be put in practice. And thank you very much for your valuable input today.
Yes, Professor. And rightly, as you said, we hope that when we meet in Kuala Lumpur, by that time we would have implemented in few of the districts to try and see to validate it and share with you.
Yeah, thank you very much. Thank you. Looking forward.
Sure. Thank you.
So I think now we have all the speakers already. I would like to thank all the speakers for their excellent and valuable input today. And we hope to see you again in Kuala Lumpur and in future webinars as well. So now we have to start the Q&A sessions. The central office, are we having speakers to ask questions through the microphone, or you will be using the chat box to ask the question yourself to the speakers?
Sir, questions in chat box only.
Okay. We have about 12 questions. Is that correct? I don't know whether the speakers can see the chat box, or you want me to read them?
Yes. No, we can see that.
Okay, the first question says that, I don't know to which speaker actually, but it says here, I see that many papers mention and discuss the SDGs, but they rarely use the official indicators and targets associated with SDGs. Instead, they often rely on their own metrics or different set of indicators. Why is that the case?
Can I take that, Professor Ragab?
Okay, go ahead. Thank you.
Thank you for the question, Aditya. I've been tracking some of the questions, and there are some common themes, so maybe I could spend a couple of minutes to address some of them. I hope, Aditya, through the presentation that I gave, it illustrated the need for localizing the SDGs and the importance of engaging communities in the process of identifying indicators that are relevant to the local context, the scale of the analysis. We all know that the scale of the indicators for the SDGs are more at the national and global level, which might not be appropriate for maybe action at a more local level. So so that's at the scale dimension. Also, context matters. So, for example, if we look at SDG 15, where we have some indicators related to forests, that might not be as relevant to a dryland country, for example, a dryland context. So not all indicators will be relevant to different contexts. Also, data availability is a big one. Identifying what indicators are we have data for in order to measure progress is critical. So I hope through the example that I illustrated in San Antonio that we gave an illustration of the need for such community engaged localization of the SDGs. There was also an interesting question by Ephraim and also followed by Subelhi Tabi, sorry for butchering the name, but talking about the need for, or whether there's a need to develop a WEF sector versus looking at more of the need for coordinated mechanisms. And I'd like to share a recent project also and the case that could be we could learn from and get some lessons learned from for other operationalizing governance frameworks in the water energy food nexus, which is a project that we've been working on for the past couple of years in Jordan, where with support of GIZ have been working on developing a governance framework for water, energy, food, environment sectors with the Ministry of Planning also in the country. We have developed that framework, which has been approved by the Prime Minister's office last year, and there's a mechanism in place now that helps or provides some mechanism for planning and implementation of different water, energy, food, environment nexus projects. And going back to the question, do we create a new sector? I don't think we need to create a WEF nexus sector, but rather a coordination mechanism that allows for integrative planning across the different sectors. Now, this is work in progress now. The creation of a governance framework is one thing, operationalizing it is another. So we'll give it some time to reflect on the lessons learned from that governance framework in Jordan, but nonetheless, I think it'll provide some lessons learned of what will work, what will not work for other countries who are interested in developing similar kind of governance framework.
Okay, thank you. Thanks a lot. There is another question here. What are some of the key areas where our understanding is lacking regarding climate risk and security of water access, as well as the connection to food and energy, the WEF nexus? Any one of the speakers volunteers to answer that? Across sub-Saharan Africa. Maybe the work of Tafadzwa related to sub-Saharan Africa.
Thanks, Ragab. Can you just repeat the question if you don't mind?
Okay. What are some key areas where our understanding is lacking regarding climate risk and security of water access, as well as its connections to food and energy and across the sub-Saharan Africa?
Okay, thanks. The understanding of climate risks is very well developed and very advanced, thanks in part to the work of the IPCC and the assessments that they do. The understanding that is lacking is more around the interconnectedness of those risks or the cascading effects of those risks and the ability to then develop adaptation strategies in Africa that respond in a systems way, what Bassel was saying, the need for systems thinking. So we are still mapping the climate risks by sector. So, in here we would talk about climate risks to water and then think of water interventions, which is where people would then think of irrigation as a response to managing the water risks to agriculture. But we often then don't link them, as I was saying, more broadly to say it's not just quantity risks, it's also water quality risks. So in many instances, especially for farmer-led irrigation development and so forth, it could create scenarios where people are using irrigating with polluted water and so forth, which has, food safety implications and so forth. So we're not making all those connections then when we are developing our strategies or even understanding how hydropower generation and so forth could further worsen or aggravate the water quality risks and so forth. So it's about having a systems approach in the design of adaptation strategies. And I think that is where we are really promoting the Nexus approach. But even within that Nexus approach, that is why we are also thinking around broadening its dimensions to say, yes, whilst we recognize the centrality of water, energy, and food, but there are also other interdependencies with environment, health, and these other dimensions that we also need to consider in that broader Nexus sort of approach. And I think that also ties in with the work that Bassel presented in terms of the multiple linkages that you are showcasing. So it's much bigger than just the 3 dimensions, although they give a good entry point in terms of starting to understand and manage these risks.
Thank you very much. There are a number of participants here. They are asking for copies of the presentation. I hope you can make them available. Could you please send me your presentation and then I will make sure they are uploaded and inform the participants about them. I'll be grateful if you can do that. Another message here about to Dr. Bassel actually saying that, do you think the SDG indicators are target and targets should be more region specific rather than relying solely on global metrics? Dr. Bassel, do you would like to comment?
Yes, absolutely. And this builds on my previous response as well. Again, the targets that we have and the indicators are meant to be more relevant at the national and global level. So once we look at more localized interventions and understanding of challenges and priorities and goals, it is really critical that we use those as a starting point, but then ask what are really the local priorities, what are the local challenges, and how stakeholders within that specific context would like to measure progress toward better water security, better health, better education, better energy security, given the local context, which is critical to anchor our analysis in, rather than try to fit those global and national level metrics into our analysis. I think we need to take more of a bottom-up approach, start on the ground, understand the local context and the metrics that stakeholders are interested in seeing in order to guide their evidence-based decision making and start from there with inspiration from the list that we have at the national level, which might be relevant or might not in certain contexts.
Thank you. There is also another follow-up message to you, Dr. Bassel. So another one to you, and it's really about considering the importance of system thinking for achieving the SDGs. Yet most countries have ministries focusing on single sectors and enhancing policies of those separate sectors. What would be the panacea to circumvent this siloed approach to implementing actions towards SDGs, do governments need to create WEF sectors as we inch towards 2023? It should be 2030, not to 23, and afterwards. If you can.
This is the question that I initially answered. So I think that is covered. And again, I think the example from Jordan by developing this kind of water, energy, food, environment governance framework could be a good case study to follow and example to learn from on what will work and what will not work moving forward. But yeah, I fully agree that we need to, rather than thinking of creating yet a new silo and a new sector, to call it the Nexus sector, to think of how we could develop better mechanisms for coordination between the existing sectors.
Can I weigh in as well, Ragab?
Yeah, go ahead.
So we discussed this matter extensively in Addis in March to say, from a governance perspective, how do we manage the Nexus? We also did a survey of ministerial portfolios across sub-Saharan Africa. In several countries, there are countries that are already starting to merge some of these ministries, where you've got Ministry of Water and Energy or Ministry of Land and Water and so forth. So there are some countries where they're merging ministries across the WEF sectors. But in essence, what we realized is the Nexus is best coordinated from ministries that have a cross-sectoral mandate already, that already have mechanisms to work across and with different sectors. And in most countries, that would be like the Ministry of Economic Planning or something like that, because it already engages across sectors. In some countries, they've got national planning commissions that are supposed to oversee joint performance, monitoring and targeting. A good example was Rwanda, where they've got that facility where different ministries actually set targets and performance monitoring together jointly. So I don't think it's about having a super ministry, but it's mostly the coordination arrangements and joint performance monitoring that need to be enabled.
Yeah. Okay, thank you, Dr. Tafadzwa. And you mentioned here there is Dr. Kofi from IMI is present. Is that correct? Is Dr. Kofi around?
Yes, please. I'm here. Sorry
Okay.
for joining late due to another event. Can I just chip in briefly?
Yeah, briefly, 2 minutes, please.
Okay, thanks. Just exactly a week ago, we had a session at the 6th African Regional Conference on Irrigation and Drainage in Abuja. We had a session on the Nexus, and it was an opportunity to bring together different stakeholders from the academia, research institutes, public policymakers, and private sector, and even some donors to discuss the issue. And it came strongly that yes, the idea actually is because Africa is at the stage where we are developing now the African water vision post 2025, and so it's critical that we have to mainstream the WEF Nexus approach in this vision as to direct how the member states in Africa will begin to do things going forward. So people recognize generally that this is very important and the approach is really very, very good. Something that came strongly was about something that about 5 I's. The institutions that are involved in planning and deploying the WEF approach, data, information and data, investment opportunities, infrastructure development, and international cooperation. very, very critical. And science will provide the data and information, all the discussion we are having, but there are quite a lot of things that are outside science around the negotiation that has to take place, in which we need to begin to look at bottom-up approach, how multi-sectoral coordination can take place to enhance the mainstreaming of wave Nexus in the planning process. That's just I wanted to chip in. Thank you for the opportunity.
Yeah, thank you. Thank you for coming on. Yeah, I thank all the. We have only 2 minutes really left from the allocated time. I would like the central office to take a photo, group photo, for the panel, for our ICID news and reviews, or ICID bulletin, and central office. Let me know when you take the photo. Is the photo taken? Central office. Is the photo taken? Hello? ICID central office. Hello?
Sir, just 1 minute.
Okay.
Wait, just 1 minute.
All right, thank you. Just let me know when it's finished. Yeah. Meanwhile, smile.
Yeah, taken, sir.
Okay, photo is taken and approved. All right, I would, yeah, officially, really, the webinar is closed. I would like, before the closure, to thank the speakers once again for coming today and sharing their valuable and excellent information with everyone. And I hope to receive copies of the presentation so the participants can really digest these valuable information on their own time and benefit from that. So once again, I would like really to thank you. And also I would like to thank the central office for taking care of conducting these webinars, and also putting a lot of efforts to help us to share the knowledge, and also for staying late. It is now late in India, and I would like to thank the central office for keeping up with really our difference in times in different parts of the world. So on your behalf, I thank Central Office for their help with the webinar, and I thank the participants for being also active and putting a lot of questions and queries to the speakers, and hope to see you in the next event in Kuala Lumpur in the first week of September this year. Thank you, and have a good day. All the best.
All right. Thank you, Professor Ragab.
Thank you.
And I'll catch up
Cheers.
with you
Thank you.
separately.
Bye.
Bye-bye.
Bye-bye.